Betelgeuse, an enormous red supergiant star situated in the Orion constellation, has intrigued humanity for many centuries with its rich crimson glow and colossal dimensions. Astronomers estimate that if Betelgeuse were to be placed at the center of our solar system, it would consume every planet up to Jupiter. This star is so massive that it symbolizes the final phase of evolution for stars like it, poised to culminate in a spectacular explosion, a supernova. In recent years, Betelgeuse has started to show strange behavior. 34 seconds in a surprising twist, its brightness surged by over 50%, pushing it from the 10th brightest star to the 7th in the night sky. This sudden increase in luminosity left scientists scrambling to find an explanation. Was this the beginning of its catastrophic end or merely a temporary anomaly in its life cycle? The consequences of Betelgeuse undergoing a supernova would be enormous. It could transform the night into day, offering unmatched opportunities for scientific discovery. A star's luminosity is influenced by factors such as size, temperature, and its distance from Earth. 1 minute and 9 seconds Betelgeuse, which has a radius more than 700 times that of our Sun, is relatively cool, with surface temperatures ranging between 3,000 and 3,500 Kelvin. This coolness gives it its distinctive red color. Despite its immense size, Betelgeuse's cooler temperature makes it a prime candidate for a supernova, which is why its recent behavior has captured such keen interest. In late 2019, Betelgeuse astonished astronomers once more by dimming to just 40% of its usual brightness. This phenomenon, visible even to the naked eye, sparked a wave of observation and debate. Some speculated that the dimming was caused by dust blocking the star's light, while others believed internal processes were at play. The idea of an impending supernova became the focal point of discussions. 1 minute and 45 seconds utilizing the Very Large Telescope, VLT, in Chile, astronomers captured detailed images of Betelgeuse during its dimming phase. These images revealed that the star had developed a distinctively lopsided appearance. Further investigation showed that the dimming was likely due to a massive surface mass ejection, SMME, during which Betelgeuse expelled a tremendous amount of material into space. 2 minutes and 19 seconds, this extraordinary event reshaped the star and disrupted its pulsation cycle. The event was akin to a volcanic eruption on a cosmic scale, with Betelgeuse releasing 400 billion tons of material, 400 times more than what a typical solar event would produce. This upheaval not only changed the star's appearance but also shortened its pulsation period from 400 days to just 200 days. These dramatic changes indicate that Betelgeuse is becoming increasingly unstable, raising the question: how much longer can it maintain its current state? 2 minutes and 53 seconds. The recent developments in Betelgeuse's behavior have prompted astronomers to intensify their observations, searching for further signs of its impending collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core collapses under the force of gravity, triggering a supernova. This explosion releases an immense amount of energy, ejecting the star's outer layers into space and creating a dazzling light show that could be visible even during the day. 3 minutes and 25 seconds. If Betelgeuse were to explode, the first sign would be a surge of neutrinos, subatomic particles that travel faster than light and can escape from the star's core. These neutrinos would reach Earth hours before the light of the explosion. Once the light does reach us, Betelgeuse would shine brighter than the full moon, casting shadows and turning night into day for weeks. A supernova of Betelgeuse's magnitude would provide scientists with an unparalleled opportunity to study stellar death in real time. By analyzing the light, heat, and radiation emitted during the explosion, researchers could gain valuable insights into stellar evolution, nuclear physics, and the formation of the elements that make up planets and life itself. 4 minutes and 29 seconds. To understand Betelgeuse's behavior, scientists are using advanced simulations to model the star's interior. These virtual models incorporate data from telescopes such as the James Webb Space Telescope, JWST, and the VLT, allowing researchers to investigate the processes that drive Betelgeuse's instability. 5 minutes and 1 second. Scientists estimate that Betelgeuse could go supernova within the next 10,000 to 100,000 years, but its erratic behavior suggests that this timeline may be much shorter. The astronomical community is working tirelessly to capture every detail of this cosmic drama before it reaches its dramatic conclusion, ensuring that humanity does not miss this once-in-a-lifetime event. In late 2023, the JWST focused its extraordinary capabilities on Betelgeuse, uncovering a startling phenomenon. Scientists discovered that, already unstable from its massive surface mass ejection, the star had experienced a rapid internal collapse. This collapse was evidenced by significant shifts in the core dynamics, which altered the flow of nuclear fusion reactions within the star. 6 minutes and 8 seconds, astronomers observed dramatic fluctuations in Betelgeuse's pulsation cycles. Before the collapse, the star's surface expanded and contracted steadily over 400 days. Afterward, this rhythm abruptly changed to a 200-day cycle, signaling a massive disruption in the star's internal structure. This irregularity is akin to a cosmic heartbeat, suggesting that Betelgeuse is nearing the end of its stellar life. 6 minutes and 41 seconds. While some astronomers believe the explosion could occur within the next few centuries, others argue that it might still be thousands of years away. One thing is clear: Betelgeuse's time as a red supergiant is running out. 7 minutes and 12 seconds. Scientists are closely monitoring Betelgeuse for any sudden surge in neutrino activity. Instruments around the world are on high alert, prepared to detect this fleeting signal that could provide humanity with its first real-time warning of a supernova. 7 minutes and 43 seconds. While Betelgeuse's supernova will undoubtedly be an awe-inspiring celestial event, visible even during the day, scientists assure us that it poses no danger to Earth. However, its brightness could rival that of the full moon, casting eerie shadows and lighting up the night for weeks. 8 minutes and 16 seconds. As Betelgeuse continues to surprise us with its dimming, mass ejections, and unpredictable behavior, it serves as a reminder of how much we still have to learn. Its potential to go supernova offers scientists an unparalleled opportunity to study the life cycle of massive stars in real time. 9 minutes and 19 seconds. The next time you look up at Orion's belt, remember that one of those points of light holds the story of a star on the edge of its destiny. What do you think will happen to Betelgeuse? Are we witnessing the final moments of a star about to explode, or is it simply another phase in its mysterious life? Share your thoughts in the comments and join the conversation about one of the most fascinating stars in the universe. Don't forget to like, subscribe, and turn on notifications for more cosmic stories that will blow your mind. Until next time, keep your eyes on the sky. As the astronomical community continues to monitor Betelgeuse, the anticipation grows. Observatories around the world remain on high alert, tracking every fluctuation in the star's brightness, temperature, and pulsation cycle. With each new development, theories evolve, some suggesting an imminent explosion, while others propose that the star is undergoing one of its final yet prolonged phases of instability. Then, in early 2025, something extraordinary happens. 0:10 and 58 seconds AM series of unusual gravitational waves ripple through space, detected by LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo observatories. These waves indicate a sudden and powerful shift in Betelgeuse's core structure, an event unlike anything recorded before. Astrophysicists scramble to interpret the data, suspecting that the star's iron core is collapsing at a rate far faster than expected. Within days, neutrino detectors around the world, Super Kamiokande in Japan, IceCube in Antarctica, and other global observatories, register an unprecedented spike in neutrino activity. This is the long-awaited warning sign. Betelgeuse is about to explode. 11 minutes and 27 seconds. The world watches as astronomers issue an urgent announcement. Within hours, Earth will witness one of the most spectacular cosmic events in human history. Telescopes turn toward Orion, while millions of people step outside, gazing toward the night sky in anticipation. Then, at exactly 0:11 and 59 seconds Universal Time Coordinated, the sky erupts. A blinding flash illuminates the heavens, turning night into day for a brief, breathtaking moment. The explosion is so bright that shadows appear even in the dead of night. The supernova outshines the full moon, a dazzling beacon visible to the naked eye. 12 minutes and 21 seconds around the world, observatories capture the event in unprecedented detail. The shockwave from the explosion spreads outward, ejecting vast amounts of stellar material at unimaginable speeds. This material, rich in heavy elements, will one day contribute to the formation of new stars, planets, and even life itself. For weeks, the supernova remains visible, a glowing remnant of one of the most famous stars in the sky. Scientists analyze its spectrum, studying the fusion processes that occurred in the explosion's final moments. The data collected will fuel research for decades, helping humanity unlock new secrets about the universe. 13 minutes and 10 seconds. As time passes, the fiery remains of Betelgeuse begin to settle, forming a beautiful nebula, a cosmic monument to a once mighty star. What was once a brilliant red giant is now a stellar ghost, marking the birth of something new. While humanity mourns the loss of a familiar celestial beacon, the legacy of Beetlejuice lives on. Its explosion reshapes our understanding of supernovae, stellar evolution, and the very building blocks of the cosmos. And as scientists analyze the data, they turn their eyes to other aging stars across the galaxy, wondering, which one will be next? The world remains in awe as the luminous remnants of Beetlejuice continue to shine in the night sky. Social media, news networks, and scientific communities are flooded with discussions, live footage, and analysis of the unprecedented event. Stargazers and scientists alike document the celestial phenomenon, capturing time-lapse images of the expanding supernova. As the weeks pass, the explosion's intensity gradually begins to fade, but its scientific significance only deepens. The James Webb Space Telescope, JWST, and the Hubble Space Telescope work in tandem, capturing every wavelength of light from the dying star. Ground-based observatories like the Very Large Telescope, VLT, in Chile and the Keck Observatory in Hawaii provide additional insights into the evolving remnants. 14 minutes and 2 seconds. What was once a bright, pulsating red giant has now transformed into an expanding cloud of gas and dust, spreading across the Orion constellation. The nebula glows in shades of blue, red, and purple, a stunning reminder of Beetlejuice's final moments. The birth of a new nebula. 14 minutes and 30 seconds. Scientists eagerly analyze the chemical composition of the supernova's remnants. As expected, the explosion has forged heavier elements: iron, nickel, gold, and even trace amounts of uranium. These elements, now scattered across space, will one day contribute to the formation of new stars and planetary systems. The supernova's shockwave, traveling at millions of kilometers per hour, begins to interact with interstellar gas clouds in the region. Some astronomers speculate that this could trigger the formation of new stars, potentially reshaping Orion as we know it. Meanwhile, astronomers detect something else. Deep within the core of the expanding nebula, hidden behind the veil of gas and dust, lies a newly formed neutron star. Some scientists even consider the possibility that Beetlejuice's collapse was extreme enough to form a black hole, though more observations are needed to confirm this. The effect on Orion's belt. 15 minutes and 12 seconds. With Beetlejuice gone, Orion's familiar shape is forever altered. One of the brightest stars in the constellation has vanished, leaving an eerie gap in the hunter's shoulder. Ancient star maps are now outdated, and for future generations, the Orion constellation will look different from how it appeared for millennia. Despite this loss, astronomers see an opportunity. The nebula left behind by Beetlejuice provides a rare chance to study the aftermath of a supernova in real time. Over the next few centuries, this cosmic cloud will continue to evolve, offering unparalleled insight into the life cycle of massive stars. A new era of exploration. 15 minutes and 47 seconds. The explosion of Beetlejuice reignites global interest in astronomy. Public curiosity about the cosmos surges, leading to increased funding for space research. New missions are proposed to study supernova remnants, while advanced telescopes are planned to observe other massive stars nearing the end of their lives. One of the biggest breakthroughs comes from neutrino physics. The sudden flood of neutrinos detected before the explosion provides scientists with a clearer understanding of how stellar cores collapse. This knowledge could one day help predict supernovae in other galaxies, giving humanity its first-ever cosmic early warning system. The future of the cosmos. 16 minutes and 22 seconds. Years pass, and Beetlejuice's nebula becomes one of the most studied objects in the sky. Amateur astronomers continue to track its expansion, while professional scientists make groundbreaking discoveries about its chemical evolution. Meanwhile, attention turns to other dying stars, Antares in the Scorpius constellation, Eta Carinae, and even massive Wolf-Rayet stars that may explode in the near future. The death of Beetlejuice has opened a new chapter in stellar astrophysics, pushing humanity to search for the next great supernova. And so, as the echoes of the explosion fade into the vastness of space, one truth remains: the universe is a place of constant change, destruction, and rebirth. Beetlejuice's story has ended, but its legacy will shape our understanding of the cosmos for generations to come.